Welcome back to Thailand, where we're currently in a break between tremendous rain and flooding everywhere in the city. But we're inside, we're nice and warm or cool and dry, and we're taking our last whack at this battery problem. So, as you remember from the previous video, the combined voltage of the series of 6 cells was overloading the voltage sensing circuit on those ADS 1115 boards. So one thing, my last desperate attempt to make this work without scrapping the whole thing is making this total sum voltage less than the total sum voltage that can be read by 3 of those boards running in parallel. So my maximum cell voltage that I'm ever going to see here is 4.2 volts per cell. We multiply that by 6, we get 25.5 volts. Now we need to get that under 6.144 volts so the chip is happy. So what I'm going to do is use a resistor network to do a divide by 5 to the differential voltage input. So if I do that, I'm going to be at a total input voltage of 5.04. So we have 1 volt worth of headroom there. Dividing by 4 is too high. Still gives us a voltage that's too high. Dividing by 3 is dividing by 6 is unnecessarily cutting our voltage down too low. I think divide by 5 is the sweet spot. It still gives us the highest workable voltage in here, and then I just multiply by 5 in software. Again, I'm not looking for laboratory precision voltage levels. I just want them all to be referentially similar so that V6 and V1 are going to come out roughly the same within a few thousandths of a volt. Doesn't really matter what that is within, again, some number of thousandths of volts. So I just want them to be consistent. So I went down, talked with my helpful electronics lady, and got some 12K and 3K resistors, and I'm going to put them into the prototype board and we'll see what happens. Okay, we've already hit our first minor technical obstacle. This is a 3000 ohm resistor, as you can see. Orange means 3, black is 0, and red is essentially 0, 0. So 3, 0, 0, 0, 3000 ohms, and you can see we're getting close to 3000 ohms. This is a 5% garden variety run-of-the-mill resistor, so that's fine. Now, these are the 12K resistors that she gave me out of a bag marked 12K. Do you see anything different? You see brown, red, black, and then another color. So that's 1, 2, 0. And then the bottom one has a brown stripe. That means 1, 0. So the bottom one is actually 1200, 1, 2, 0, 0. The top one is 1, 2, 0, 0, 0. That's 12K. That's the one we want. And it's quite difficult to see the color difference. Focus. But the one on the bottom, second from the right, is brown, and the top is red. You'd think the resistor manufacturers would make a slightly bolder color to differentiate the resistors. But it's a good thing that I bought 10 of them, because 6 of them are actually 12K, and I can just put the other 4 into the bin. So I get to continue with the experiment without getting on my motorbike and going back down to her shop again. Okay, I just soldered in our first resistor divider. The voltage, this red used to be right here at the top of this power resistor. I've now got the 12K and the 3K wired to here and here, which represents this part of the circuit for battery number 1. And I measured the cell at 1.505 volts. Let's see what we get on the input to the A to D board. Okay, here is the battery itself, 1.503. Here's the input to the board, 0.299, 0.300. That is nearly exactly divided by 5. So it works on one cell. Let's try another one, because we always know we get in trouble when we add one more to the system. Okay, let's check the voltage of the second cell now that I have the resistors wired in. 1.544, so we should see something a little bit higher than 0.3 volts when I put the battery in the circuit. So let's do that. And I come over to the screen, and we're at 0.309 volts on the cell 2, which is that's pretty good. But the voltage on cell number 1 has jumped up to 1.534. So my naive drawing of the voltage divider has introduced yet another interaction between the battery cells, and this just ain't gonna work. Now, luckily, Shaky Traveller has come through with a beautiful resistor ladder divider system and done all the calculations, and I will rebuild the system with that in mind and come to you with a new video soon. As you stare out on my beach, I would ask you to subscribe to my channel and click like on this video so YouTube thinks I'm worthy again, and I have so many people on my channel that they'll give me 10 cents a day in ad revenue. So I thank you for that.